Okay. Test 1, 2, 3. So this is part 2. Last time I did the first 30 questions. And I'm pretty proud. That was 5.6 minutes per question. And also there's like decent explanations. I was pulling up Excalibur and stuff. So for any of these first 30, these are like the most popular questions in the last 6 months for Facebook. Just go to that previous stream, I guess. It's like chaptered. Just gonna pop into it. I'm gonna try and keep track of, I guess, how many I've done. I noticed the mic was a little bit wonky before, like the damping was a little bit overboard, but whatever, I'm already streaming. I'm just gonna pop the first one up. And I've done probably all of these. I think I'm probably not going to do them as fast as last time because there's more hards the less frequent they get, but we'll see. Next permutation. Oh, God. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. So the using constant extra memory is what makes this, like, to me, a nightmare question. These questions are the bane of my existence. So it all comes down to like keeping track of what is ascending and what's descending in nums. So if my memory serves me, you're going backwards. Let's say we have a random, let's say print. Let's say print. I think this should work. I'm just trying to like, population must be a sequence. I'm trying to just generate something to copy paste into Excalibur. Here we go. Okay. So we have our random sequence of numbers, our random permutation of numbers 0 through 10. I guess it should really be 1 through 10, but whatever. Here we go. So we have this, and now the next permutation, this is actually a great example. The next permutation is going to be the first spot where you can increase going from the right. Like, we're never going to want to mess around with the 1 and the 10 if there's something to the right of that that can be changed. Or I guess like the 2 and the 1. Like there's some later permutation that would be 2, 1 as opposed to 1, 2. But we might as well, like, the next permutation is going to be something more to the right, if there's anything more to the right. If there's not anything more to the right, if it was like 1, 2, 0, then we would want it. Then the next permutation, I think, would be swapping the 2 and the 1. So it'd be 2, but it wouldn't be 2, 1, 0. This is always what trips me up. It would be 2, 0, 1. So going back to this example, I think what we want to do is look from the right, because we want to find the rightmost change that we can make. That's going to be the smallest kind of increase to this whole sequence. So we're going to say, look at the 8. If, let's say, there was no 3, it was just 8 and then 9, and the 3 was like here. Then we would say, okay, 8, okay, 9. There's not really any, like, we don't want to swap anything yet. And then the moment we find a 3, then we say, okay, now we want to swap something in. So what's the smallest number we've seen before this 3 going from the right? Well, that's going to be this 8. I guess it's always, it's always going to be the last thing we want to slot in here. And what is with these arrows? So we would say, okay, put the 8 where the 3 is. Now we gotta like change everything around. Put the 8 here. And then everything from there on out would be increasing. So then put the 3 here and then put the 9 here. So we would, yeah, we would put the last element in the position of the first element that's smaller than the thing to the right of it. And then everything after that would get sorted. And I think the part that makes this a more tricky is that sorting this, if there was a bunch of random stuff here, if we had like 3, 4, 5, 6, 9, like the thing to recognize is that definitionally this would have been in the opposite order, because we were looking for the first thing. We were looking for, let's change this one to be that too, because it's a more interesting case. Because we were saying 8, okay, 9 is larger than that. Oh, look, we found what we're looking for. 3 is less than 9. That means that everything after the 3 is going to be descending, or going from the right. We will have been looking at it in like in ascending order. And the fact that we know that this is purely descending and we want to rewrite it to be purely ascending, lets us do that in O of n time and O of 1 space. But if I can just sort that anyway and not have too many issues, I'll be happy with that, because this is a lot of pointer BS in my mind. I'm gonna keep that. That's actually pretty nifty. So I guess we just start from the right and we say pivot equals n minus 1. And then we say while, or I guess pivot equals n minus 2, while pivot is greater than or equal to 0, because there's a world where we just go off the edge, and nums at pivot is greater than nums at pivot plus 1. So this is saying like, okay, while we have a situation like the 9 and the 8, decrease pivot. Okay. And then we're going to find we're either going to have something like 3 and 9, or we'll be off the edge. So we could just have a corner case that's like, if pivot is -1, then we know the entire thing is descending. We know we have something like 3, 2, 1. And in that world, we just like return the opposite. So I'll just say like, for now, and maybe I'll bother to go back through later, but I'll just say something like nums, write into nums, nums backwards. So just if it was descending, now it's ascending. So that covers that corner case. Now all we're left with is we've found something that's smaller than the thing after it. So up until this point, if we've been parsing everything in ascending order, I'm gonna delete this. That's like not. There we go. And then let's have this be like what the correct answer will be. So it'll be, we write in an 8 here. If we've been parsing everything like 8 and then 9 in an ascending order going to the left, then that means that nums at -1 will always be written into nums at pivot. And then nums at pivot plus 1 will now be what nums at pivot is. And then nums at -1 will be nums at pivot plus 1, and so on. That's where the pointers come in. But hopefully, if I do this right, I can kind of just do something similar to line 9. So I'll say x equals nums at pivot. We got to save this. And then nums at pivot equals nums at -1. We write in the next smallest thing. That's always going to be the last thing. And then nums from pivot plus 1 and on is going to be nums from pivot plus 1 and on is going to be pivot itself. plus, should do that, pivot itself plus nums from pivot up to its last thing. So like it's going to be the 3 plus the 9. So we're going to put the 8 in there, and then we're going to have the 3 and then the 9. And this should be the next smallest thing, if I'm not mistaken. That should be pivot plus 1, I believe. Yeah. Okay. Oh, no, wait. Except, what am I talking about? That should be X. And then nums at pivot. Yeah, that looks right to me. Ooh, what? Okay, it's void. We're not returning anything. I guess return nums, I don't know. Okay. Oh, I don't need this. I don't need this here. All right, if this just works, then I'm going to count my lucky stars. Yeah. So here, 1, 3, 2, I guess what the logic should be doing is saying, should be saying, come from the right. Everything's ascending. Pivot will land on 0. Yeah. And now it should say, put the 1 where the 2 is. Okay. So you're not always putting nums at -1. I think you're finding, like what my logic is assuming is that the 3 will always be smaller than the 8. But you could easily have this be like 3 and then 9 and then 8 going backwards. And what that would do is you would only really want to swap. What would you do? You would say, okay, now the 9 goes where the 8 is. You wouldn't want to put the 3 where the 8 is because that would be an earlier permutation. You would say the 9 goes where the 8 is. The 8 goes where the 3 is. And the 3 goes where the 9 is. So I think you could I think you could still do, I think it's like a minor modification. Instead of nums at -1, let's say nums at pivot equals nums at pivot plus 1. And then nums from pivot plus 1 on is going to be equal to, it's just going to be like the sorted sequence from everything after that. So I bet if we said like sorted this 3, 2, 3. Oh, okay, yeah. Well, is this even right? Nums at pivot is nums at pivot plus 1. No, it's going to be the first greater element. Well, I think I'm overthinking this. I think I don't even have to say nums at pivot equals nums at pivot plus 1. I think I just say like nums from pivot on equals sorted nums from pivot on. I think that's all you have to do. Okay, that's absolutely not all you have to do. 1, 2, 3. So the pivot will be 2. It's going to be the first element that's greater than X is what you're looking for. So I guess I'll have like another index going backwards. So I'll say idx equals n minus 1 while nums at idx is less than X. We know at is less than X. We know at some point, because of this while loop and this if statement eliminating the corner case, that there's going to be something after pivot that's greater than pivot. So we'll say idx plus equals 1. So now idx is going to be the first thing that's greater than pivot. The smallest thing that's greater than pivot. So then we say nums at pivot equals nums at idx. And we've saved x, so we don't have to worry about having erased that. And then we're going to say nums at pivot plus 1 equals, actually I'll say nums at idx equals x. And then I'll just say nums from pivot plus 1 equals sorted nums from pivot plus 1 on. Oh, oops. Oh fuck, it's like not, I'm sorry. Darn, it's not even, there can be duplicates. I don't think that changes very much though. 151, what will this do? I guess this will be 115, but really the answer is 511. Okay, yeah. One, 5, 1. So this should say the pivot is 0. And then it's saying, great, you have to move this pivot. So I guess this is just less than or equal to x, so that it doesn't run into that specific issue. Is there any other situation? Because I definitely was being really liberal with these less thans and less than or equal to's. Like, is this correct? Nums at pivot is greater than nums at pivot plus 1. Yeah, because I think if you had like 115 and you were looking for the next thing, I guess so. Maybe this was supposed to be greater than as opposed to greater than or equal to. But if both of these are accepted for all of these, this tells me that there's a corner case that's going to mess this up. You're saying decrease nums at pivot is greater than or equal to nums at pivot plus 1. Oh wait, yeah. So what happens if you have, well, I guess 511. That should go to 115. So that's right. Whereas if it's purely greater than, then it throws an issue. So yeah, greater than or equal to is correct. Are there any other greater thans or less thans I need to keep account of? Nope. No. Okay. So I think that accounts for the repeats, and I think it's good then. Whew. As far as this goes, I mean, sorted returns a list. So this is for sure O of n space, which isn't great. And I think there you could be fancy about this. You could say nums at pivot equals nums at idx, nums at idx equals x. So in like this example, that's a bad example. Let's go to this example. Well, let's like generate a new one, I guess. I don't know that I'm going to implement this out because these questions really irk me. But let's see. Yeah, here we go. So you're going, let's say instead of 6, 5, 7, this was like 7, 6, 5. So you would go backwards. You would say, okay, 1 and 8. Let's say that, just to make this like a really good example. So you would go backwards and then you would say 5 and 8. Aha. Okay, what's the next largest thing? The 6. So then you would swap the 5 and the 6. And if I'm not mistaken, that would mean that from pivot on, this is always still purely descending. Or not purely descending, but non-ascending. And then you would just reverse this, if I'm not mistaken. So I think you could say, instead of sorted nums at pivot plus 1, I think you might, and this is where the optimization comes in, where you can still do this in linear time and O of 1 space. Instead of nums at sorted nums at pivot plus 1 and on, you would say go backwards 2 nums at pivot. Just reverse that section instead of sorting it, because it's descending, you can just do that and it's ascending. Yeah. And I think this literally might even be O of 1 space because of the way that slicing works, because this is like returning an iterable. And if I said like print nums at this, then it's going to cast that kind of to a list. But if I'm slicing it, I think it might even be smart enough to have this be an iterable and do this one element at a time. So it's still kind of O of 1 space, and now at the very least, this is definitely O of n time. But I'm sure in an interview, they would really want you to do it with pointers and not do like a hacky Python thing. Okay, minimum add to make parentheses valid. Okay, yeah. So with these parentheses ones, the trick is that you always just go from both sides, because you look at these examples and you go, oh, this, okay, well, you want to add a paren there. Or example 2, you're like, okay, well, I obviously want to add 3 parens at the end, but probably the corner case that trips everyone up is like, what if you had 2 closed parens and then 2 open parens? And the only way to really register both of these efficiently is to go from both sides. So for C and S, minimum add, so we just have to return the number. So I'll say res equals 0, and then say, and also like cur equals 0. And I'm going to do this twice. So if C is specifically equal to an open paren, then I'm not even going to do an if statement. I'm just going to say cur plus equals C is equal to an open paren. And then I'm going to do some lame math, but this is just where my mind is going, and I don't want to think about an if statement here. I'll say equal to this times 2, because this is either going to evaluate to 1 or 0. It's going to evaluate to 1 if it's an open paren and 0 if it's a closed paren. So times 2, now it's going to be 2 if it's an open paren and 0 if it's a closed paren, minus 1. So now it's going to be 1 if it's an open paren or negative 1 if it's a closed paren. And now that's like, rather than evaluating this as a like 1, 0 Boolean, it's now like a 1, negative 1 Boolean. I use this kind of expression constantly. So now it's going to add 1 if it's an open paren and subtract 1 if it's a closed paren. And then if cur is less than 0, that means that there's like this situation where it's opened out with a closed paren. So then we say res plus equals 1, cur plus equals 1, because cur is always only ever going to be negative 1 because it can only decrement by 1 at a time. Okay, and then we just have to do the same thing backwards. So we'll reset current, and we'll just say for C in S, negative 1, and then this is going to be a closed paren instead. So just like look at everything backwards. Cool. Custom sort string. Given 2 strings, order and S, all the characters of order are unique and were sorted in some custom order previously. Okay. Permute the characters of S so that they match the order that order was sorted. So we're sorting by S according to the order of sort. So here C would be first, and then B, and then A, and then D. Okay. Yeah, I feel like it's going to be like return sorted S key equals, I think you could do order dot index, and it's going to be smart enough to know, okay, you're taking a key from each character and then you're indexing through order. And I don't think order can be that long. Yeah, so this is still kind of O of 1. And then we have to translate this back into a string. Substring not found. Okay. Yeah. That's not too bad. I think this one-liner can be salvaged. It's going to be order plus ASCII lowercase dot index. So now it's like, if it's not in order, just go to the very end. Nice. This does make it be up to, I guess, like, if order had 26 characters, then this is 52 characters, which is still linear, but a little bit questionable. Merge K sorted lists. Okay, so heap. Heap is the answer to this question. Once you see it, it's very obvious. So it's saying like, how do you do this efficiently? Oh, and they're list nodes. Interesting. The idea is you just always append the next lowest list node. So we'll say like h equals lists, just because I like using h and heap pop h and heap push h. And then we'll say heapify h. In fact, it's not just going to be lists. H is going to be we need like a flag. The way that Python works, like a priority queue can only be expressed using a heap, and a heap is just like always a min heap. So we need to use like a tuple, and then the first thing in the tuple is going to be the flag element. Then the second thing is actually going to be the list, the list node. And it's just going to be like l.val. Okay, heapify h. And then we're going to say sent equals list node. While h, and we also need like tail equals sent. So we'll say node equals something, and node equals heap pop h. Tail dot next equals node. Tail equals tail dot next. If node dot next, heap push h. Node dot next dot val. Node dot next. And then it should do that. And then we just return sent dot next. Getting familiar with sentinels is really okay. Let's see, heapify h. Oh, So it's saying you're putting this value. Okay, it says each linked list is sorted in ascending order. It's like a dumb issue. The issue is it's saying like you're putting two things in a tuple, but the second thing isn't comparable. Huh. So we need like a reference to that. How do we do that? No, that's okay. That's fine though. Because what we can say is l.val in the index for the index and the linked list node in enumerate lists. And then we actually like, instead of saying like heap push the next node, we're going to say heap push this index again. So instead of like referencing each node, instead of like immediately saying lists is now a heap of nodes, we're going to sort of keep using lists as just a way to index each of these linked lists. So blank IDX is heap pop h. Node equals lists at IDX. And then here we also say if node next lists at IDX equals node dot next. Heap push, just for the sake of consistency, it's not really necessary, but lists at idx.val, idx. It kind of checks out. None type has no attribute val. Oh, they can just be empty? If L, I guess. Kind of, I feel like these linked list binary tree questions, they always are like, oh, it's not quite complicated enough. What if we had the null entry? Hey, you're okay. You're okay, buddy. Go settle. Okay, I was looking at my dog. But these ones are always pretty cut and dry. It pretty much just comes down to like how's your flood fill? How are you with traversing through 2D grids? So I like to say immediately, let's define our directions. So up, to the right, down, and to the left. And then it's saying number of islands. An island is surrounded by water formed by connecting adjacent lands horizontally or vertically. You may assume only four. Okay. Yeah. So I could see someone kind of going number of connected components. This seems like disjoint sets. But it's not really necessary. Just the way it works out, like disjoint sets are really useful if it's like online comparison. If you have to say, what if this one was a 0 now? Now how many islands are there? What if this was a whatever? Like then disjoint sets are really useful. But here you can kind of just go square by square and flood fill it. So you can just say for I in range n, for j in range n, and I assume actually it can be rectangular. Oops. Hopefully I wouldn't get docked for that in an interview. Mn equals length of grid. Length of grid is 0. So then it's just going to be, you can do a stack or a queue. It doesn't really matter. I think in Python, a vector is a little bit faster than a deck because of the way that the deck works under the hood. So we're going to do a bunch of logic here, and then we're going to have something that's like res equals 0. If not grid at I at j, continue. And you don't even need a set for this. Like a lot of these, you need some kind of scene set that's like, have I seen this node before? But here you don't even, you can just like modify the grid, which is terrible practice. But in fact, I am going to use a scene set because that's a really garbo practice. Like normally what you can do is just be like, if grid at I at j continue, or else grid at I at j equals 0. But that's, you're destroying the thing that they're giving you just to find the number of islands in it, which I assume in a real world scenario, they would never want you to destroy the thing. So we'll have a scene set. We'll say scene equals, and I'll actually not have it be a set. I'll have it be like a, an array so that we don't have to use hashing because it's a little bit faster. So now we have to be able to encode and decode from this 2D matrix into a 1D array. So we'll just make a little lambda function that's like encode equals lambda I and j. And then it's just going to be I times n plus j. Probably takes less lines to just write this on the fly every time, but whatever. Okay, so now instead of that, we'll say if, we'll still have that, if not grid at ij, because there are actually zeros in there. And then we'll also say if encode ij, if seen at that, then we've already seen this, so continue. And then we'll say res plus equals 1. We found a new island. We've set foot. Stack equals that while stack I and j equals stack dot pop. Seen at encode I and j equals 1. We've now seen this for di, dj, and d. I'll say x comma y. I actually am trying to not use x and y as the alternative I and j, because a lot of the time for like geometric things, you want to use x and y for something else as well. So I'll say I1, j1. I guess I could have said k and l, but whatever. Equals I plus di, j plus dj. If 0 is less than or equal to I1 is less than m, and 0 is less than or equal to j1 is less than n, and not not seen at encode I1 j1, and I'm going to put this here because I like having my not at the end so I don't have to have any parentheses, and grid at I1 at j1. So if there's another connected piece of island, then seen at encode I1 j1 equals 1. Do I want to have this here? Yeah, that's fine. That means I don't need this here anymore, so I'll do that. And actually, oof, this was a close one. Right here, I say I'll get to this in a second. But I actually just almost made a pretty classic mistake here. Stack.append I1, J1. Okay. Then in the end, we return res. So you kind of flood fill through the island. But the mistake here that I made is defining I and J as stack.pop. And actually, I think I am going to use X and Y. This is exactly the kind of thing that I'm talking about. Where like you start to have all these loops and everything starts to be like all the obvious variable names get taken and you have to start using like K and L and X and Y and stuff. But the reason why it's better, to do this is because before I was rewriting I and J every time, but the outer loop is for I in range M for J in range N. And what would happen is like normally that would be kind of okay. Like, oh, you're defining J, but then the next iteration of the loop, you come back around, J is going to be redefined to what you want it to be, and I will be redefined to what you want it to be. But for every single row, once you redefine I here, it's not going to be redefined until you reach the end of that row. So it's going to mess everything up, and you're not going to be able to like, your J will be fine, but your I is going to be all augmented and weird. Let's see. Oops. Sure, there's going to be a couple of those typos. Okay, 1 and 3. So it only prints it once. Encode, encode, encode. Let's see if it even makes it down there. Okay, all the zeros, all the ones, all the twos. That looks good. So it is checking everything. Let's also say seen at encode I and J. Yeah, so everything's getting marked as seen for some reason. The moment actually from 0, 0, everything gets marked as seen. So that tells me that here it's not really registering zeros properly. Yeah, we can see from 0, 0, every single square is parsed. X1, Y1. That's kind of surprising. Grid at X1 and Y1. Okay, so I think it has to do with the logic of this if statement being a little wonky. Because I'm printing grid at X1 at Y1 right after this, and it's printing a bunch of zeros. I don't think I can just say like doesn't equal 0. Hmm. Okay, 2, 0 should be 0. So this is true, this is true, this is false. Grid at X1 at Y1. Maybe I do need parentheses over this stuff. I think it's very likely there's some like X and Y thing that I retyped incorrectly. Oops. Let's put that there, I guess. 1110. That's so odd. Grid at x1 at y1 is 0, and yet this loop is true somehow. Man, it's gonna smack me in the face, I bet. What happens if I literally copy paste this statement? Like that must evaluate to false, right? Now it's evaluating to true over and over again. So like literally this part of the statement is evaluating to false. And yet all of these chained and statements are evaluating to true. Grid at x1 at y1. Okay, what happens if I say cast this to a Boolean? Oh, okay. Dumb. It's that it's like, oh, it's a 0, but it's a 0, but like it's a string of a 0. So it's still evaluating to true. What happens if we just say grid at x1 at y1 equals 1? Oh, and okay, and also there's another problem now. Right here, if not int grid, is that all the references to grid? I think so. I mean, it'd probably be a little faster if I just pre-processed that. Like up here, if I said, now grid is a series of integers and not strings as it insists on being. But again, I went pretty far out of my way to not actually modify grid. So I'm gonna stick with that. Valid number. Oh no. Valid number can be split up into these components in order: a decimal or an integer, an e followed by an integer. Decimal can be split up into these. An integer can be split up into these. Okay. So I guess the first thing to do is say if s can't just be nothing. Yeah. If s and s at 0 in EE, s equals s from 1 on. Now we've taken care of that. Can't it be? Yeah, it can be like 2E10. But it can't be like, hey, we'll settle. You're okay. An E followed by an integer. Oh, it's not listing off. It can either be this or that. It's saying it can be at first a decimal or an integer and then an E, which makes sense. I guess you can't just have like E10. That doesn't mean anything. So I guess I'll say like def check S, and then that's going to do something. And then I'll say like for blank, for word in, I'll say for substring. Now is not the time for brevity. For substring in s dot split E. How do I want to do this? Because it could either be a capital E or a lowercase e. If E in S. It can probably have multiple E's, right? Consists of only lowercase English letters, digits. Okay. I don't think there's any way. Yeah, I think the moment that there's anything other than an E, it's kind of kaput. So I think before I do anything, I want to check for that. I want to say like, if E in S, return all map check And then I'll say like star s dot split e. And then I'm going to do the same thing with this. And then I'll just say in the end, return check s. Okay, so that's handling the e's. And then I want to handle like there being multiple e's or other characters or something. So I'll say c equals counter s. For char in ASCII letters, if char in EE, yeah. Return 0. So we've checked to make sure that there are no other characters. That's fine. And then we'll say like if C at E plus C at capital E is greater than 1, return false. Okay, that handles that corner case of any letters and multiple E's. So that's fine. Now it's just the check function, if I'm not mistaken, being like, does this make sense? Does each side of the E make sense? Okay, so leading zeros are fine. Can you have a leading plus sign? Yes. Either plus or minus. So I guess the first thing you do is you say if s at 0 in plus minus, s equals s from 1 on, and then you do it again. You say if, I guess if not s, return false. You can't have just like 1 e minus or something. And then also if s at 0 in plus minus, return false. You can't have minus minus or plus plus, it looks like. Okay, so the polarity is taken care of. I guess like if s dot count dot is greater than 1, return false. You can't have multiple dots. And then I think it's just a matter of like num equals, for num in s dot split dot, if all, what do we want to say? Lambda c dot is digit num. If not all, then return false, return true. So that's like everything on either side of the dot is a number, and you've gotten rid of the polarity. I think that would work for all of these. I don't see any issues. All takes exactly one argument. 2 given. Oh, I think this is like a key. I was thinking of it like map or filter or something. Maybe not. Okay, whatever. I can just say c dot is digit for c and num. Okay, it says e is true. So I think we say if not s, return false. Because if you have an e anywhere, if you have just nothing, that's not possible. But you could have just an e, and just an e anywhere. You can't have like 10e or e10. So that gets rid of that. Okay, it doesn't get rid of that. Oh, because when it's s dot split e, I think that's like nothing. It's like you have now just this empty. No? Okay, it's 2 empty things. All map check s dot split e. I think I don't need these stars. I think that's like confusing it. Yeah. Now it's appropriately like printing an empty line, so you can't see it, but it's printing an empty string. Okay, just a dot is returning true. That's kind of the same thing here. This all, it should also be like if not num, return false. But is that true? You could have like, that's fine. Yeah. So I guess we'll say if num marked equals true. Actually, that's like overcomplicated. I think instead I'll just say return any s.split dot. So it's saying like you have to have 4 dot or 0.4 or something like that. Okay, this is the point where empiricism beats out theory. Yeah. Okay, this is false for some reason. So 6e 6.5. Can it not be e by a float followed by an integer? Okay. Yeah. I guess we'll just say like we gotta split these up a little bit, but that means the first thing can be a float, the second thing has to be an integer. Yeah, I guess it's not really IEEE standards to have like 1.1 e 1.1. That doesn't really make sense. I think I'll just have like an isInt here. That's all fine. That's still the same. If s.count dot is greater than 0 and isInt, return 0. Okay. And then if it's not, then dot split dot should just be the whole string. Then num will just be everything and it'll do the right stuff. Okay, and then here we'll say like, what are they called? The Matisse? No. It's called the, there's a really fancy name for it. Like the two sides of the E, but whatever, I'll just say base and exponent. Or order, I guess. Equals s dot split E. Return check base 0 and check order 1. Okay, and this is gonna be the same. Looks like there was a typo there anyway. Return check S and 0. I think if there's no E, then it can be a float. All right, let's find the next error. Hey, that was surprisingly clean. I thought that was going to take way longer. Okay, moving average from data stream. Lord knows I'm not going to understand what that said. Given a stream of integers in a window size, calculate the moving average of all integers in the sliding window. Oh, of the last size values in the stream. I guess just have a queue, right? Self dot sum equals 0. And then we'll say return self dot sa equal length of self dot q. If length of self dot q is greater than self dot size, self dot sum minus equals self dot q dot pop left. Self dot q dot append val, self thoughts plus equals val. Okay. Whew, really a quick one. Copy list with random pointer. Construct a deep copy of the list. Jesus. Oh, okay. None of the pointers in the new list should point to nodes in the original list. Where each new node has its value set to the value of the corresponding original node. Okay. So it's just saying like, that's fine. That feels like you just use a hash map to keep track of it. And it's going to be a little fancier than that. What happens if I say something like test equals head colon head? Like, is this hashable? That is hashable. So that means that we can just directly say like new head, something like that. And just be like, what corresponds to this old thing? What corresponds to this new thing? So I'll say, and is it cyclical or anything? No. I hope. I don't think so. I mean, if it's cyclical, I'll take the error, I guess, but it makes no mention of that. Okay, so tail equals head. And then you're just going to go through. I think it's just going to be like, we'll have a translation hash map and be like, while tail trans at tail equals a new node. And the val is going to be tail.val. Next is going to be tail.next. And then random will be the next loop. That looks good. Okay, tail equals head. While tail. It's going to be tail equals tail.next. In the end, we're going to return trans at head. So then here it'll just be trans at tail dot random equals tail dot random. Ooh. Node with label 13 was not copied, but a reference to the original one. Oh, I see. Okay, it's because I need to say trans at tail dot random equals trans at tail dot random, because we want we want the copy of tail to refer to the copy of tail's random pointer. Wild tail, transit tail. Oh, it's because tail.random could be none. Let's see. Let's just make sure this is like even doing that part. 7, 13, 11, 10, 1. Looks good. Node 13 was not copied, but a reference to the original one. Oh, right here. It shouldn't be pointing to tail.next. There should be an extra thing that says trans at tail.next equals trans at tail.next. If tail.next. I'm just going to say if tail.next, else none. Gets it all in one line. Although is not none really should be like, because you never know. Right here, you're saying just implicitly evaluate this to a bool. And I think the default bool cast is like, is this a thing or is this none? And if it's like a list, then it's like, is it empty kind of a thing? But you never know. Like there could be some update down the line where they're like, now list node has a bool cast. And it's like, if its val is 0 or not. And then that would like really screw this up. Classic. I like to think in an interview they would say, what if I submitted nothing? And it would be slightly more forgiving in that way. Okay. Shortest path. 8 directionally connected. I'm going to delete this so I have to retype it because it's slightly more realistic. The length of a clear path is the number of visited cells in this path. The shortest clear path. Okay, everything has to be 0. I think the first thing to do is check if grid at 0 is 0. This is the kind of thing where I'm like, man, this would cost me 5 minutes on the contest if I didn't think of this immediately. I get that with a lot of like return this modulo 1e9 plus 7, or I just forget it and it's like, oops. That's the same here. I feel like there's a corner case that's like, if grid at 0 is 0. Return -1. Like if you're starting and the first thing is 1, then you can never do anything. Okay. And also, okay, these are integers. I don't have to worry about that. This is going to be 8 directions. So we got north, northeast, east, southeast, south, south, southwest, west, and northwest. Fine name. So I guess we would just have like res equals 0, turn -1, and then we'll have something that's like q equals dec 0 and 0. So the syntax here is like make the dec from an iterable, which is itself a list that we're going to make that's going to contain the tuple 0, 0. So it's a lot of parens and brackets. And then while q, c is length of q, oops, blank in range c. So it's like a level order traversal, res plus equals 1. So we'll say I and j equals q dot pop. And then I guess I'll also do the scene thing again, because I don't really want to be like erasing the grid. That would be weird. Scene equals, it's a square grid, so. Okay, in the beginning, nothing's seen, and then we'll say encode equals lambda I and j, n times I plus j. So now we have a way to like encode any 2D coordinates to this like 1D encoding of all the 2D coordinates. I don't think I'm going to check for scene here. I guess I'll start and say scene is 0 equals 0 is 1. So we don't have to check that original thing. Okay, I and j is q.pop. For di, dj in d, I1, j1 equals I plus di, j plus tj. And not rated I1 at J1. And I'm going to have this before. And not seen at encode I1 J1. We'll say Q dot append left I1 J1 seen at that equals 1. Okay, and then we need the actual like win condition here. So that's going to be if, I guess I'll just say whatever, I equals n minus 1 and j equals n minus 1, return res. So if the array is a 1 by 1 square, it should return 0. If it's like this, it should return 1. Okay, so it looks like we want to return 1 or 2 in that case because the number of nodes, not the number of edges. So here it should be 1, 2, 3, 4. Yeah, I think it'll be fine here because it'll add these two nodes, the top right and the middle right at the same time. And then the middle right will propagate before the top right marks that as seen because this is a queue and not a stack. So I think it should be okay. There it is. All right, 40. I think I might just do 15 today. We'll see. What time is it? 107. So I'm making pretty good time. 1 second. Yes. I got to change the problems done. I've done 9 problems. Okay, given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. All right, so this is a 2-pointer thing. Say L equals 0 for R in range nums. Define all our stuff. With 2 pointers, it's really good to use a for loop and not a while loop. If I said like L and R are both 0 and while R is less than length of nums, like I think it can feel more flexible, but that's kind of a bad thing because when you have for R in range nums, you have this loop invariant where you're like, what's the best I can do when this is the right bound? What's the best I can do when this is the right bound? And it kind of allows you to think more concretely compared to if L and R are like moving around amorphously. That's like really sketchy. So we'll say K minus equals, I'm going to say 1 and nums at R, 1 XOR nums at R. So it's like if nums at R is 0, then K goes down by 1. We have to have used a single K. While K is less than 0, K plus equals 1 XOR nums at L, L plus equals 1. And then we'll just say MSF equals max MSF. It's going to be R plus 1 minus L, because like if they're both the same, we want it to be 1. That looks pretty good. Oops. Cool. Add strings. Turn the sum of num1 and num2. Okay, so that's just like, I mean, oops. Oh, okay. If you were trying to not do that, I guess I would have 2 pointers. I would say like carry equals 0 for, and what did I just say? If you have 2 pointers, it's better to use a for loop than a while loop. Yeah. So I'll say for IDX in range max M and N, and I'll define those. For some of these, I'm doing like a hacky cheaty thing because fiddling around with pointers for O of one space is kind of stupid. But here, like, this isn't an O of one space linked list BS question. This is like, this is actually the point of, if you just said like eval or some with int, that really is like you're dodging the question and the interviewer would be really disappointed. Okay, so we have that. And then I think what I'm going to do is I'm going to have IDX iterate from 0 to the max length. And then the first thing at the top of every loop is it's going to say IDX equals max of M and N minus 1 minus IDX. So we're sort of like translating it to be from the 0th to the last. And then for num in num1, yeah, that's fine. For num in num1, num2, if IDX is less than 0, continue. And then we'll say carry plus equals int num at IDX. So we'll be like carry plus equals 3, carry plus equals 1. And then we'll say res dot append string of carry %10. So look at the ones place of the carry, and then carry over equals 10. So if carry was like 11, say we added, 7 and 6, carry would be 13. We would say, okay, append a 3, and then also divide it by 10. So now we're carrying a 1, and now we're adding 7 and 5. That's going to be 12 plus the 1. Yeah. And then in the end, return, I think it's going to be .join res backwards. String index out of range. Oh, minus 1 minus, oh. It's because right here, really what I want to say is not, I want to have this max thing right here, like inside of this loop. So I'll say I equals length of num minus 1 minus IDX. Oh. If carry res dot append string carry. So this is like if it wraps over and both of them carry. But you don't have any number to like actually register that. You have to just look at carry alone. Okay, what was that, 11? Oh no. Stickers to spell word. Maybe I'll have to stop at 12 because this one's going to take a minute. We're given n different types of stickers. I'm going to take a second, actually. I totally forgot to paste the stream link, but whatever. It's good to think on it. It's probably the wrong question to, you good boy. He hears the B word and he gets worried. That's adorable and sad. This is the wrong question to start posting the stream link around. Or it's the right question because it's not a matter of rote memorization. So you have any number of stickers. I'm assuming the constraints are rather small. Yeah, there's only 10. So this feels like a DP kind of thing. Yeah, because target.length is 15, right? So 2 to the 15, that's going to be like 30K. 30K means that we could have like, let's call, so this is N, let's call stickers.length M. We could have like M squared times 2 to the N if we wanted to. I know this is going to be some form of DP, so I'll get down like a recursive solution, and then if it's like really slow or if it's trivial, then I'll turn it into an iterative solution. So it's going to be like def DFS something, and probably what this is going to look like is like, what's my state space going to be? You always got to think about this with DP. It's like there's kind of a few questions. There's really 3. There's state space, transition, base cases. Let's go ahead and make the state space a little bigger. So what's the state space here? Well, it's going to be O of 2 to the N, probably. And that's partially just looking at this hint and knowing that that would work. And that's kind of being like, can I get away with brute force? Yes. So probably I want to look for a way to just do that. If I can even figure out that, I'm good to go. I think this one's weird because you're like a dude cutting out letters from the magazine. So you don't even care about the order, really. Like if you're looking at width, you're just like, I have a T, an H, a W, and an I. What can I do? I can get rid of a single T. And the order just doesn't even slightly matter. So you could maybe sort this and do something clever there, but I don't even think you would want to do that. I'm thinking this is one of those weird situations where in a way there's like a worse time complexity than even 2 to the N. 2 to the N, you'd be like, okay, I have a mask representing that I've knocked out that, and I've knocked out that, and I've knocked out that. But I think you could just have like the counts of the letters. So you could just be like, I have 2 T's, I have 2 H's, I have 1 E, and I have 1 A. So what that would look like is like the hat. This would be like, you would say 0, 1, you have a single A, you have a, let's say E is 5 or something, I don't know, 0, 5. Is that right? No, I think it's 4 because it's 0 index. And then let's just say T is like 15. I don't really know. You'd say 15, or no, what am I doing? This would be 3, 1, 15, 2. And then you would also have your like H, let's say that's like 7. I'm not really that interested in thinking about the order of the alphabet right now, 2. So you'd have the counts of each character. Yeah. I think you could compress it further than that. Because here you'd have like 0 through 20, 25. And any of these numbers could be anywhere from 1 to 15. So if you were like really, really worst case, you would be like, well, that's 15 times 26. 2 to the that would be absolutely awful. But you have to recognize that actually it's a maximum of 15 total ever. The max, it could be 15 A's, but there can't even be 16 tuples here, or 26 tuples here, because you can't have A through Z. That's more than 15 letters. So I think like that's kind of a trick that probably one would do well to recognize. And there probably is a clever way to do this with bit masking, but again, like I'm not that preoccupied with that. I think you can like just straight hard do this with tuples because the constraints are so lenient. So I think what you want is like the index of the word that you're currently at. So that's going to be anywhere from 0 to 50. And then also the current count of the target. And this could be anywhere from, I mean, like saying 0 to 15 isn't really valid. It could have anywhere between 0 to 15 characters, but really like it's a little bit difficult to describe the complexity of this dimension. It's not just like there's 50. The dimension of the state space here is going to be like any number of tuples. And I think at worst, that's 2 to the 15. Because if you were keeping track of the placement, if you said, I've gotten rid of this H, or I've gotten rid of this H, like that's more complex than just saying, I've gotten rid of an H. You could probably even do this with the word itself. You could just have the whole word. But I think it's better to encode it into frequencies. I think that's like better time complexity. So I'll just say like frequencies. And then, yeah. So what this will roughly look like is if the frequencies are empties, then that's when you return 0. It takes no more stickers to do anything because you're done. And then you want to say like use this word or don't use this word. So there's one thing you could do is say like I guess we'll say MSF or res, which you're going to return in the end, is going to be equal to DFS of I+1 frequency. So try not using this sticker, or try using this sticker. So say I think I'll pre-process. I'll just say like stickers equals counter S for S in stickers, so that I don't even have to worry about like doing that every single time. So then I can say for C and F, in stickers at I. So like for each character and each frequency, I think what I want to do is say like frequency equals list frequency. So like turn it from a tuple, because ultimately it's going to be this like serialized hashable tuple. I've done, I guess this is on, I'm on my 11th problem right now, or I'm on my 12th problem right now. I don't know if it shows up in the corner. I'm trying to like toy around with the OBS settings. I think I got to change my mic settings too, because the like threshold where it stops picking up my voice is all messed up. But anyway, we'll have the frequency within the sticker, and then that will change this target frequency that we're looking at. So we'll say, I think it might even be worth just having frequency always be a length of 26. Just being like, and there's a bunch of like 0, 1, 1, 0, 2, 0. That feels inefficient, but it also feels like you're only going to increase a factor of up to 15 to a factor of constant 26, which I don't think is really going to be the worst. What do you mean it shows? Oh, the text? Yeah. But if I keep frequency sparse, like this is going to be only a length of 4 as opposed to a length of 26, which is way better. I think I can keep it sparse, but I can keep it sorted. I think that's the move. Because if I keep it sorted, then I can use 2 pointers to go through. I could say for C, F and stickers at I. And actually, I'm not even going to do this. I'm going to have this go from 0 to 25. So like everything is an integer. And then I'll say like, for C, F and stickers at I, IDX equals 0. While IDX is less than length of frequency. And frequency at idx at 0 is less than c, idx plus equals 1. And then right here, I'll say if idx equals length of frequency, break, because you're done. Okay. But then I say frequency at idx at 1 minus equals f. And then we have to say frequency at idx at 1 equals max frequency at idx at 1 and 0, so it doesn't go negative. Okay, so now frequency is changed accordingly. And then you could say, actually here, frequency at idx is a tuple. So really it needs to be frequency at idx equals frequency at idx at 0. I think it's worth also like having this be dynamically sparse. Because I was going to say like just subtract it out from frequency at idx at 1. No, this is fine. I'll do that in a second. Frequency at idx at 1 equals frequency at idx at 0. Frequency at idx at 1 minus f. And then I'll just say like max of this in 0. Okay, so now this is like a tuple again. It's just an edited tuple. So that removes one set of issues. Okay, and then you got to translate frequency itself back into a tuple. So that could just be like res equals min res DFS of I and tuple of frequency. You could just do this, but I feel like you can do an optimization that's like frequency equals any frequency equals x for x in frequency if, and actually it can just be turned into a tuple here, if x at x of 1. So like if there's still any frequency, then you still have to look at it. A lot of usage of the word frequency here. Okay, that looks good. I think this will just go forever in TLE because it's just going to keep trying word 0 over and over and over again. So I think it's good to have like a marked setting. It's like marked equals 0. Marked equals 1. So if you're actually like subtracting any letters, then you want to keep doing this. Yeah. Or else don't bother with this. Okay. Oops. Okay, we want DFS of 0, and I'll just define frequency outside. So I'll say frequency equals, I think the quickest possible way would be tuple, map, tuple, counter, target. Sorted target. And this needs to be counter sorted S. Oh, if not frequency. Oh, yeah, okay. So if not frequency, and then there's one more that's if I equals n, or length of stickers, return infinite. And then here it's going to be if DFS of 0 and frequency is not infinite, or else -1. Tuple index out of range. Frequency, Frequency at IDX is 0. Max of 0 and frequency at IDX at 1 minus F. Okay. Frequency has been cast to a list. So when it says tuple index out of range, that means it's like frequency at IDX is where it's taking issue. Okay, so that's definitely an issue up here. Oh, I think it's that I'm saying sorted target dot items. I think if I just say sorted target, or no, counter dot items. I guess if you just map a counter to a tuple, then it doesn't include the counts, which is kind of odd. Oops, one more layer out. Okay, yeah, so now it's including the frequencies. So what I want to see is not that. I don't really care about that. So it's got AEHT, looks good. It looks like it turns into a generator object as opposed to a tuple, which is not what's supposed to be happening. It's interesting that it looks like a generator object is registered as hashable though. I think that's happening right here. Yeah, okay. So A1H2. So I think that means that with, well, okay, this is at index 2. So it's gone through with and example. So it looks like it's taken out all the T's and the E's, and it just has 2 H's and an A. So that does make sense to me. What's the answer I'm getting? 2? If not free, I mean, maybe I'm just like off by 1, but I doubt it. Okay, that one makes sense. -1 is let's see, 2. So I'm saying you can pass up on this sticker, or you can use this and add 1. I think I'm going to say print I frequency res. What's the best we can do with a given I and a given frequency? Okay, if we made it to index 2 and we still have an A, then we're screwed. That makes sense. Okay, if frequency is empty and we've made it to index 2, then the answer is 1, which I don't think is right. Yeah, that's a really weird. No, that makes sense. I think I'm doing something really janky here, where I'm turning this into a tuple so that it's hashable, so that I can use a cache, and then I'm unpacking it into a list and then turning it back into a tuple after I've changed it. So really, when I'm looking at I and frequency here, this is like terrible for readability, but I think that's part of what makes this problem difficult. This frequency right here, this isn't saying, hey, when you input into DFS index 2 and an empty frequency, the answer is 1, because that should obviously just trigger this if statement immediately. This is like after frequency has been changed, after the letters have been removed from whatever is at index 2. So probably here it removed the E, and then frequency is now 0. So that makes sense. Index 1 getting to 0, is that possible? I think that is possible, because you have 2 E's here. You have an H and a T here, so you use this twice, and then you use this once, and then you're good. Okay, at index 1, if you have 2 H's, the answer is 2, which shouldn't be right. You shouldn't ever be able, if you're at index 1, you've already passed up the H's, so you have no way to get any more H's. At index 2, if you have a single A, then you're screwed. That's also wrong because you have an A in index 1. I think this is the most curious part. At index 1, when you have no frequencies, when you have nothing you're even looking for, the answer is 1. What I'm going to do is I'm going to say print frequency stickers at I, and then do it again because it's probably something wrong with the transformation. Okay. Kind of headachy. Okay, with science, that's fine. That kind of returns nothing. When we're looking at example, that gets rid of the E's and the A's. It also seems to get rid of the T's, which is not correct. Okay. It's because right here I'm saying like get to the correct index of the character. This is just saying get to the next index of a character that's greater than the current character, but it could be different. So if IDX is length of frequency, if IDX doesn't equal C, the frequency at IDX is 0. Doesn't equal C, continue. Okay. I'm not really, there's definitely some optimizations that this can make, but if this just kind of passes, then I'm gonna call that. The main optimization I'm thinking of is translating everything to numbers instead of characters. Because when you compare characters, like right here, when it says frequency at IDX at 0 isn't equal to C, it's more readable for like print statements to have these be characters, but you really just want these to be values from 0 to 25. I'll just go for it. There's a good chance this TLEs. Oh, okay. Looks good. This problem is interesting because the time complexity is really weird. If you're like, I feel like it's so rare to have a tuple of frequencies as the input that you're caching. Given an integer num, you can swap 2 digits at most once to get the maximum valued number. Return the maximum valued number you can get. 2 digits at most once. I'm guessing this isn't saying like, I'm guessing this just means you can make one swap. So 2736, you would want 7236, 9973, you would want to not swap anything. Okay. I think the thing to do is if it's non-ascending, then you're good and you don't do anything. If you're looking for the first thing that's ascending. So here, this 2, you would swap it with the 7, or you would swap it with a 9 later on. You're looking for the first example of anything that is less than something later. And then you would swap it with the largest thing available. So it's relatively clear what to do. It's just the implementation is a little bit hairy. It's like the next permutation problem from earlier. So I think the thing to do is be really explicit and say num equals int x for x in string of num. So now the whole thing is a list of integers. And then say c equals counter num for x in num. I'm really used to typing nums. I think you could kind of say like c at x minus equals 1 for y in range x plus 1, 10. So look for if there's anything larger. If c at y, that means that there's something larger than this after it. And I think we really want to say like 9 comma x comma negative 1. So we're counting down. So look for the next largest thing. And then you would want to, okay. You're looking for the largest thing after a given digit. So if you know that that's the largest thing after the given digit, then you know that that thing is also larger than everything else around it. Oof, that gets ugly. Like if your number was like 2, 3, 4, 5, 9, 6, 7. No, it doesn't get ugly. The premise of the question is you always exactly swap with that number. But if you had like 2, 3, 9, 4, 5, 9, 6, 7, which 9 do you swap it with? You would always swap it with the last one because this will always be the largest number. So you say for IDX in range, length of num, -1 minus 1 minus 1. If num at IDX equals y, then you swap them. So you say num at IDX equals x and num at I equals y. Yeah. This looks good. Oops. Wait, are we returning a number or okay, yeah. Is this indentation right? So it's saying, I think this needs to be there. Yeah. Damn. I'm glad I dodged the bullet on this question. This can be really ugly. I guess it's the deduction that like any number after a given number, if you're looking for the largest number after that, then it's going to be larger than everything else after it too. So you always want to take the last instance of that larger number. Okay, this is sweep line. This is like the sweep line question. Given 2 lists of 2 closed intervals, each list of intervals is pairwise, disjoint, and in sorted order. Return the intersection. Okay, no, this is not sweep line. Or no. Yeah, it is. Yeah, this is totally sweep line. So we can kind of say events equals did I want to do this? Yeah, events is that for start and end in L, and then I'll say for L in first list, second list. So for each start and each end of each event, events dot append S1 and E -1. So you're like, when is an event starting and when is an event ending? And adding 1 counts as starting an event, and subtracting 1 counts as ending an event. And because we know that these are disjoint, I think you can just say like events.sort. There's always a little bit of a question of like, what happens if an event starts exactly when another event ends? It looks like that counts as an interval. So here at second 5, one thing ends and another thing starts, but we do include it. So I think that we don't have to do any custom sorting. What we might have had to have done is something that's like key equals lambda x, x0, negative x1. So it's like if there's a -1, put that before the or after the 1. Wait, is that what we want to do? This will start the event, and then we say, yeah, okay, no, we do want the custom sort because we want to have the 1 register before the -1. Okay. Sweep equals 0 for event, or for time, but it doesn't really matter, and event or event type in events. Sweep plus equals typ if sweep. And then we'll have like a res. Res is that. So if sweep, that means that we've just added 1. No, we want to say if sweep equals 2, that means that there is an overlap. Then say res.append time. If sweep equals 1 and the type is -1, then res at -1 dot append t. I think that's all we really have to do. There's probably like a line I'm missing, but maybe not. Oh, there we go. I think this is slower because you have to sort it. And I actually don't, like, you could do this smarter. You could interpolate both. You could like add both of these into events 1 by 1 and not sort it. So it wouldn't be n log n. It would just be n, but whatever. Return a deep copy of a graph. Okay, this feels really similar to the like clone a linked list question. It feels exactly the same. So with this one, I feel like just use a dictionary. There's not really any mention of can you do it in O of 1 space, so whatever. So I don't have like a translation dictionary. Actually, there's something important to check, which is, do these nodes that they're giving us, are they hashable? Yes, they are. If they weren't hashable, each value is unique, so it wouldn't matter. In fact, I'm going to do that because that's way better practice. Like just assuming that this data type is hashable is kind of sketchy because it's a memory address that would be hashed, but also there's like a list in the node that isn't hashable. So I feel like that's like bad programming practice to try and hash this. So really what we're going to have is something like node.val is going to be like new node. Okay, so I guess a stack is fine. I think a stack is okay. What are we returning? Return a deep copy of the graph. I assume like the copy, we're giving them back the node in the graph that they gave us. So we would eventually say return trans at node.val. Okay, trans is that, stack is that. While stack, you want to say trans at node.val equals node.val. For neighbor in node.neighbors, if nade.val not in trans, stack.append neighbor. Yeah, but you gotta actually have this right here. So for each neighbor, okay, add it if it's appropriate. And then you want to say trans at node dot neighbors dot append trans at neighbor dot val. So for each neighbor, the neighbor's not in the translation. Interesting. It's just 3 nodes over and over again. One, two, four. Oh. Oh, it's because I never even pop off the stack. None type has no attribute val, so it's one of these if not node, return none. You must return the copy of the given node as a reference to the cloned graph. Oh, it's because I'm changing it around. Cool. Was that 15? I'll try to make it 220, I guess. Course schedule. This is like the top sort question. Turn true if you can finish all courses. So the idea is you have it in degrees. Or UV in rec. Okay. Looks good. So the idea is you have these in degrees, and they represent like how many current prerequisites a given class has. And you just start with everything that doesn't have any prerequisites, and you say for all things that have this as a prerequisite, subtract 1, and then if it doesn't have any more prerequisites, then add it to the stack. Then in the end, it's just, does anything still have any leftover prerequisites? Because if so, then you can't take all courses. Okay. Oh, this is a cool one. Letter combinations of a phone number. I might try to use matrix multiplication for this because I've been practicing that. Oh, never mind. This is not what I thought it was. Given a string containing digits from 2 to 9, return all possible letter combinations. Yeah. Oh. Oh, this is not what I thought it was. Okay. So I guess it's going to be something like state is equal to nothing, or it's going to have an empty string in it. And then 4 digit in digits backwards. I'm going to have like a translation that's going to be equal to, okay, 0 is nothing, 1 is nothing, 2's ABC, 3 is DEF, GHI, JKL, MNO, PQRS, TUV, WXYZ. Good to have a little refresher on the alphabet. Okay, so go backwards with the digits and say new state is going to be that. I don't even think I need, yeah, I should have that. I'll say for C in letters at digit. And I should map these to be an integer. For C in letters at digit, new state plus equals C plus word for word in state. And then state equals new state. That looks good. I don't think there's any like such thing as no combinations. You could collapse this into a one-liner, but that's not very readable. Oops. Looks good. Okay, that was 17. I got 3 more. Insert into a sorted circular linked list. Okay, I just did this problem like last night, I think. Because someone was talking about it. So my strategy is being shamelessly having just done this, is you're going to go through, you're going to have like your previous node and your next node, and you're looking for the spot where either the node you're trying to insert is between those, or it's like outside of the entire circular linked list. The question is saying you have this circular linked list with an arbitrary entry point node that you're given, and the whole thing is in ascending order, and you want to insert this new value. I guess first things first, if not head, return net res, and then I'll say res equals node insert val. And then res.next equals res, because it needs to be circular if you're starting the list. Okay. So the first thing that I think is important to do is find out if every number is the same. Because if every single number in the sorted linked list is the same, then you could just cycle it endlessly, waiting until you find a new number, but you won't ever find a new number. I don't know if that's necessary, but I think it's important. And it lets you show off the, what is it, Floyd's cycle finding algorithm, where you have fast and slow pointers. So you say fast slow equals head.next head. And then you say while slow doesn't equal fast, slow equals slow.next, fast equals fast.next.next. And then before that, you're going to have something that's like, if slow.val doesn't equal head.val, break. And then the same thing for fast.val. And then if you didn't break, then you just have a really simple like head.next equals res.next equals head.next. You can just insert the node anywhere and it doesn't matter. Or else then you're saying like node equals head, prev equals head, node equals head.next. And then you're looking for a specific predicate. You're looking for something specific to happen. Man, 2 hours in, still going strong. So while something, and then you're going to say node dot next equals res dot next equals node, and prev dot next equals res. So what we're looking for is either while while not node.val is less than or equal to res is less than or equal to prev.val. So you haven't found a spot for it. And not node.val. This is backwards. It's prev.val is less than or equal to res is less than or equal to node.val. Or prev.val is greater than node.val, and this is pretty disgusting cascading logical statement. Res.val is greater than or equal to prev.val, or res.val is less than or equal to node.val. Damn. Okay, so it's something up with one of these cascading if statements. I'm saying prev.val is the center equal to, so that's fine. Or prev.val is greater than node.val. And not that. Prev.val is greater than node.val. And I'm going to refrain from just changing random greater thans to greater than or equal to's. Oh, it's returning super early. That's why. It's returning at the wrong point. There we go. I just had my cycle finding algorithm kind of messed up. Oof, okay, that one's done. 2 more to go. Closest binary search tree value. Okay. I mean, I think the point of this is to do it in logarithmic time, but I'm getting hungry, so no, I should probably do this in logarithmic time. So I feel like you're looking for the in-order successor. I don't even know if there's a way to do this in logarithmic time. It's a binary search tree, but it's not height balanced. So if you're looking for an in-order successor and predecessor, those could easily be O of n time if it's just like a big linked list. Yeah, whatever. Cache, def DFS. I don't even think I need that. I think I'm just going to have like a stack. While stack cur equals stack dot pop. Child in cur dot left, cur dot right. If child, stack dot append child. Return MSF. Okay. And then we'll say if abs of cur.val minus target.val is less than abs of msf.val minus target.val. Oh, we're just returning the value. Okay. Uh-oh. Oh, I guess you have to like truncate downwards or something. Print the smallest answer. Okay, yeah. Okay, last one. 2 hours and 10 minutes. Vertical order traversal of a binary tree. I'm going to read this and then go pee real quick. For each node at position row call, its left and right children will be at positions row +1 call -1. Okay. Vertical order traversal is a list of top to bottom orderings for each column index, starting from the leftmost column and ending on the rightmost. Oh, okay. There may be multiple nodes in the same row and same column, and then they need to be sorted by their values. I guess you just have a 3D. I don't even know if I need to go to the bathroom. This is a more approachable hard problem. I think you do a level order traversal, and you have some sort of like res, and res is going to be, it's going to be a dictionary of lists of lists. Yeah. Hey. Boy. And you could get away with no hashing by like scouting out to begin with and being like, what's the furthest negative column that there is? And then you could just have that be 0. Like it would be 0 indexed. Maybe I will do that. That seems like a good challenge to add on to this. How would you do that? I guess you would just be like def dfs node call. I think I'm going to do this with 2 DFSs because doing it with a level order traversal is like not even necessary at all. Okay, so def scout with a node and a column. Then I'm just going to have like self.min call equals 0 because you always have the root node at the very least. Self.min call is that. Okay, so now we found the minimum column. I guess we need the maximum column too to have like the length of the array. Times max call minus self.min call. Okay, be right back. Okay. Hopefully my mic isn't too messed up this time around. Okay, so we have that. And this is just going to be a separate DFS. You could definitely do this iteratively, but whatever. That's going to have a node and also a column. Then in the end, it's going to be this void function where you're going to say, perform a depth first search with the root. And then the starting column, I think, is just going to be negative self.minCall. Like if minCall is -1, then you kind of want the 0th column to be at index 1 in the ultimate result. And then in the end, return res. Yeah, that makes sense. So the first thing you're going to do is, I guess you also need the depth too. We'll say that starts at 0. Ooh. Yeah, how does that work? So then res is really going to be a default dict list. It's not the prettiest, but is that what makes sense? You want, yeah, that's fine. That's fine. So the first thing you're going to do is you're going to add this. You're going to say res at call at depth dot append node dot val. And then for child in node dot left. No, I can't do that. Okay, so you add one or subtract one from the column, and then you add one to depth. I think that's all you need to do for the DFS, and then you kind of need to just translate res to be the right thing. So I guess for every column in res, there's a default dict. So you're really just laying those end to end. I think you could say, what happens if you say like res equals map reduce res? So you're saying like for everything in res, for all these default dicts, call reduce on them. I think what that will do, reduce's default operator is add. And add works with lists to just append them together. So it should append together. I don't think it'll do that because it'll try and do that on the keys, if I'm not mistaken. Unsupported type, oh, oops. List index out of range. Let's see. Okay, I guess it's max call +1 minus min call. Okay, it says min call is 0. Oh, because I never actually call scout. Okay. Max call is 0. Oh, because I never set max call to be a maximum. Okay, that looks good. Okay, yeah, so it doesn't like reducing res. So I guess you could say, I think you could do chain from iterable. Chain dot from iterable. So you take an iterable of iterables and then you combine them into an iterable. I think that's what you want. So you could say or just do like a big list comprehension, I guess. So it's going to be something for call in res. So for each column, you're going to have like, yeah, it's going to be like for the height in call.values. It's going to be the sorted height. So everything from smallest to largest. Oh, but it hates that. This is where the chain from iterable comes in. Oh, there we go. List index out of range. Zero, one, two. Is that the right? Zero, one, two. So min call should be 0 and max call should be 1. And then it's saying for blank in range 1 plus 1 minus 0. Makes sense. There it's saying min calls -1, max calls 2. That's clearly something else. Oh, but they're both 0. Oh, because this is max call. What a dumb typo. Eight zero three six one four five. I say 7-2. It says 2-7. So that's probably an issue with them being at the same height, but I'm registering them at different heights. That's what I would imagine. Yeah, it looks like I'm saying 7 is at height 4 and 2 is at height 2. So if I look at this test case, that seems right to me. Or is it in descending order of, no? Wait, what do I say here? Do I say 7-2 or do I say 2-7? I think I say, oh, I say 7-2. Okay, so 7 is at a height of 4, 2 is at a height of 2. Ah, I see. But I traversed to the 7 first. So I need to not just say chain from iterable. I need to say, oops, for height L, and then it's going to be sorted array for height and R in call.items. But then it's going to be sorted call.items. So it's also sorting by height. I guess that's where the level order traversal would have made this a little nicer. But I guess this is still pretty speedy. Kind of surprising. This feels like one of the slower implementations you could have. 2 minutes, 25 seconds. What's that? 145 minutes. Over 20. 7.25. That's not too bad. I'll take that. Whew. Oh, that's all of them. I'm gonna go find some food. See ya.